Good? Green? Perfect. Love it. Hi, my name is Grant Case. I work for Dataiku as an analytics architect, working specifically with data science and analysts and Tableau customers. Over the last 6 years, I've worked with 200 plus customers across the country, all in and around analytics, machine learning, and data visualization. I'm actually an old OG when it comes to Tableau. Tableau 4, I was the second purchase of Tableau inside of Citigroup about a decade ago. So I love Tableau, always have been. So this talk is all about ending the guessing game. How can we take visualization and data science and bring them together to come to better solutions? So with that, what I want to talk about today is the use case. So all props to Interworks, who actually, if you were here at TC 2017, actually came up with a great, fantastic use case of, would you be flight delayed if you were leaving Las Vegas? Now, how did they do that? They made a fantastic interactive dashboard in Tableau, but what's on the backside of that was Dataiku. So what we're going to talk about today is how Dataiku created predictive analytics and also the inference to understand how weather impacts your flights. So, in addition to working for Dataiku, I'm an adjunct professor at Columbia University in the Masters in Analytics program. So I'm going to do a quick primer on machine learning, and then, of course, demo time. Let's actually look at what's going on and what's happening. So when I talk to my students and when I talk to new customers and they're making their way down the machine learning path, I always talk about prediction versus inference. So the way to kind of think about it, prediction is, am I going to be accurate? So in the case of a weather, if my flight delayed, right? I can start adding variables about my weather data, about what's happening at the hubs around the US, about flight numbers, about time of day, carriers. All of these variables we can start to put into the function or the model to actually start to understand if a flight will be delayed itself. Now, prediction in this case is all about how do we predict if that flight is going to be delayed. We only really care if we were correct or not, and that is okay. So typically when we're talking about prediction, is somebody going to buy something from us? Or if I send a mailer out to someone, are they going to return it to us? The techniques used to estimate that are all about, and the functions and variables are all about minimizing that error. The bottom one, and probably all of you who have worked with Tableau, are all coming into this concept of inference. What is inference? Inference is trying to understand why something happened. So as you're going into a Tableau dashboard, you're starting to drag and drop onto the canvas. You're trying to understand, okay, what variables, what correlations are actually impacting my cost of goods sold, my revenues, my ROI, whatever that might be, right? So the key takeaway to understand is prediction is I'm always trying to guess whether I'm correct or not, right? Inference is really, and I like this, I can actually explain what that prediction was and how I got to it to a board member, right? And those are two key important aspects. Now, the second set of discussion I want to talk about is bias versus variance. So as you're building models in machine learning, as you're trying to understand and how you're trying to understand your data science or your problems, you start out with what's referred to as high bias. So high bias is all about, hey, I throw a variable in and I think a result's going to occur. Your model sucks if you have a lot of high variance. It's very simple. A lot of this ends up being conventional wisdom. Who deals with conventional wisdom all day? Every day, right? Everybody's hand should be up, right? So what do we do with Tableau and what are we doing work? Well, with Tableau and the visualizations, we're trying to understand the correlations. We're dragging things on the dashboard. We're trying to get to some sort of understanding of what variables are impacting, right? But the human brain can really only take about 3 variables at any one time and try to correlate them in their head. The wonderful thing about algorithms in general is they can take hundreds, thousands, tens of thousands of variables. So the most complex model I know of was a former IBM distinguished engineer. She had a data set of 10 million variables. So it was 1 0, and if you actually had visited a website or not. And their whole concept was they had to make within 0.8 of a second of whether or not they would buy a digital ad, right? So it had to be very, very fast. So when they're using all of those variables and when we're using the algorithm can actually figure those out. Now, as you train that model, you got better and better and better, right? Well, what happens when you decide, okay, I'm gonna take that data and put it on something else? So here's some new data I don't know the answer to. That's when we start to get what we refer to as validation error. And you can also start to overfit, meaning if Grant was here at this time in this area, well, Grant's gonna be right here, right? Well, I'm not gonna be right here come Friday, I'm gonna be on a plane back to New York. So that's where we start to overfit in terms of variables. Your model sucks here too. It means it's too complex, there's too many variables, maybe, and that's ultimately not good for you as well. That's where you might end up in like Excel hell, right? So you're throwing everything in there. Now, I bring all of this up to you because ultimately, we at Dataiku with Interworks, we're trying to help you get past these elements. We want to make it easy for you to understand and consume your data, just like Tableau does. We have wonderful ways of pushing that data into Tableau. So ultimately, let's take a look at this use case and try to understand how we took this concept of creating a great interactive dashboard and then push that out to the Tableau community. So with that, let's go into demo time. So the first thing I want, if you've been here before, and if you were at Tableau 17, you saw this dashboard by Interworks. Will your flight be on time from TCC? So ultimately, we were collecting commercial flight data, analyzing that data, cleaning it up, and then creating a model. So how did Interworks did that? They basically have their own application and their own dashboards and, their own JavaScript to run all of this. So you select your airline, you select your destination, your departure and end time, and ultimately what happens, right? What happens is a great looking Tableau dashboard. So everything that's going on in this Tableau dashboard, oh man, son of a bitch. Yeah, that's fun. I always love fun. So, there we go. Oh, you've got to be kidding me. So we're going to do this live. There. So that Tableau dashboard, and while we're doing that, we'll just do this, is ultimately trying to ferret out the variables and importance of what's going on and what's happening. So what happens, right? So you're submitting your stuff and you're ultimately getting some variables back. Now this dashboard is basically looking at TC18, right? So TC18, what weather's coming in? But when we're building models, we're ultimately trying to do that for both sides of the house. We're trying to actually understand both the inference, why something happened, and the prediction of can it happen again. So what you're seeing on the screen is Dataiku. We are a self-service analytics and machine learning platform for data science. We work inside of projects inside of Dataiku. And part of that starts to actually build up the analysis. So what were we trying to do as a part of this analysis? Well, we were going to source data from different locations. We were going to transform those calls and transform airport call IDs, massage the data in many of the same ways you do. We build a list of the hub airports, and why, right? Anybody want to take a guess of why we would build a list of airports? Well, guess what happens? Inside of the community, inside of when we're having flights, those hub airports, if they start having issues, even if we're here in Louisiana and we're not having problems and there's no rain, if there's a massive thunderstorm over Atlanta, guess what happens? Delays go out from the hubs. So this is actually part of what you do as a Tableau analyst. You're actually figuring out, okay, I can start to look at this variable. Okay, if Charlotte has a problem, that means American flights are going to have issues, so therefore we should probably look at that. So something that might impact an American flight may not impact my flight, right? Because maybe I'm flying Delta through Denver. And then ultimately, we're going to build that model. So how do we build that model? Well, we're taking a number of different variables of importance, we're bringing them together, and ultimately, we're going to push that result out. So those results can go to web APIs, like a REST call, which what Interworks is doing. They actually hit, every time you make a call, they're pulling that data out and they're rescoring that model each time. We also could throw out to batch, we could throw out to Tableau. So ultimately, whatever that production lifecycle for you is, we're there to help be a part of it. Think of us as more of upstream of your dashboards and of your analysis. So, how do we do that? What's going on here as part of this process? So what we have in the middle of this screen is what we refer to as a flow. It's a directed acyclical graph, and it basically is an instruction set. So just as you actually start to build a project and you say, okay, I'm going to copy this file down, I'm going to process it in one way, I'm going to run my dashboard, maybe you're good at scripting. This isn't in fact what we're doing as in a project sense. So also part of projects is trying to collaborate. So how do we collaborate? Well, we start to have discussions amongst our team. So we try to build that into the tool as well. So as we start to analyze our data set, as we're kind of pushing things back and forth between Tableau, we're trying to understand what happens. So just as you would actually start to do and work in data, we also start to work in data as well. So what makes your job easier as an analyst is actually going out, looking at the data itself and understanding what's happening. And God dang it, so what do we do in Tableau, or what do we do in Dataiku? We make the data easy for you to understand. We start to sample it, we start to understand it. We ultimately give you the concept of being able to see your data. As you transform data, as you visualize that data flows along in a pipeline. So machine learning, data science is ultimately a pipeline of what you're doing, and you as an analyst, you as a data scientist, we all believe everybody's got to be on the field. So we can no longer work in silos. So how do we do that? We bring everybody together. So how do we do that from a machine learning perspective? Fucking sideways. Well, we start to take out components like random forest, decision trees, different machine learning algorithms inside the tool. So we can take a normal set of data variables, and start to understand it from an interpretation and a variable importance perspective. Remember I was telling you earlier that we were inference versus prediction. So how do we start to understand what our data sets are doing? So we try to understand what variable importance. So a part of the dashboard that Interworks had created was ultimately trying to elicit what that variable importance is. Well, how did it get there? Well, it gets through the algorithm itself, whether we're talking about a supervised algorithm like random forest or decision trees or XGBoost, or we're looking at unsupervised. Any folks in marketing do a little segmentation work, right? Yeah. So how do you segment? You're probably figuring out, okay, you're creating a persona. Jill is between the ages of 25 and 34. She's urban upscale, right? Part of how you can do that is actually take unsupervised machine learning, such as two-step or k-means clustering. Ultimately, why is it important? Why do we care? Ultimately, that clustering capability starts to elicit those instance variables in what's important about Jill, what's important about what she does and who she is. And that's the algorithm's job. You're letting your data tell the story. Just like you let your data tell the story when it comes to Tableau, the algorithms help you tell that story in the best way possible. And the algorithms themselves can actually tell you about the variables that might impact you. So back to this particular flight delay, right? What's important about flight delays? Well, do you believe flight number would be important as a flight delay? Probably yes, right? Because what happens a lot of times, and as a former United employee, you will bake in ground time, right? You already know that flight's gonna be delayed, but you as a end customer, you want that flight to leave at 11 o'clock, but I know for a fact you're not gonna get to JFK before 3:30. So what do? I already bake it in, right? So that's how we try to understand. That's why flight number would be important, because I see Delta, I see that flight number, and I know exactly what's gonna happen. Now, also part of understanding what you're doing is trying to understand, were you true or not? Back to that predictive side, right? So what's important sometimes when we're talking about machine learning is the prediction component being, hey, is it better for me to be correct? Or is it better for me to miss? And that may be important, right? So if I'm spending $200 or $300 to try to acquire one customer, that's a lot of money. I probably want to be always absolutely sure, because I have a very finite budget. That's what we refer to as a true positive, right? So, but what if I have a $3 million, any manufacturing folks? In manufacturing? What happens if on the line a machine breaks down, right? That's probably a couple $1,000,000 that line goes down. You got to send everybody home, right? That's when it says, you know what? If I miss, that's okay, because I'm going to send a tech out and they're going to spend I'm going to spend $200 because there could be $200,000 if I have to shut down that line. So that becomes part of this process of this machine learning and the visualization. And this is also about the confusion matrix. So as we start to work inside of Tableau, you can start to show people off. It's like, hey, what's the cost? What's the cost of something occurring, right? So we try to do that. Now, ultimately, the big answer for any model, right, is whether or not you are actually correct, if we're talking about prediction. How do we do that? What you're seeing on here is a lift chart. This is something you can actually do yourself. Anybody done a lift chart in Tableau? Perfect, awesome. So lift charts are, all this is trying to do is trying to understand how much better is my prediction versus randomness, right? So the straight arrow, so the left to right is really just, hey, if I took random guess, what would that answer be? The top one is the wizard being, if I made a perfect guess. Ultimately, I want to be above that line, right? What happens if I'm below that line? You're worse than random. That means it's awful. It means awful. That's the folks that you want to go to Las Vegas and they're betting one way on the game. You bet the other way, right? Because that ultimately, that model is telling me it's a better answer overall. So again, when we start to talk to folks, like, what is a model? Man, you have to be able to understand and talk to your clients, talk to your business end users, talk to your CFO, your CIO, your CTO, because ultimately, while these are they may appear to be very complex in how they're working, ultimately what's going to happen, so all of this is going to be we're all going to be doing this. In the next 2 to 3 years, I've seen it happen. I was there at the very beginning on the data discovery side. I looked at it and I said, you know what? Tableau, this is life-changing. Anybody, is it life-changing that you've worked with Tableau? Has for me. It sent me, basically, I spent my entire career at Citigroup basically building Tableau and helping work on things. So ultimately, as we start to understand how models work, how they start to work with our data visualization, it becomes so very, very important to understand both sides of this house. The visualization side, meaning, hey, can we make it interpretable? Can we build things like growth charts? Can we build things like rock curves? To ultimately, while they may seem very complex, if we start to think about things like over here on the right-hand side and how we discuss these things, it's pretty simple. Hey, so long as this is going up to the top left, we're in good shape. The more we go up into the top left, we're in great shape, right? That's what visualization does. Visualization can help us find the variables of importance. In a 10 million variable product or data set, you probably are not going to want to try to do correlations each time. Let the algorithm do it. If you're trying to understand what my revenue, what's driving revenue, well, you know what? I can go out and actually do that. I can do that Tableau dashboard and start to actually make it and understand that variables. One last point I want to leave you as you talk about and you understand what's going on in this world, right? You as Tableau analysts are on the front lines of what's going to happen over the next 2 to 3 years. This concept of data scientists sitting in a void where they don't know, we had the old programming adage, take the pizza box and just slide it under the door, right? A little bit of that data, it's kind of becoming in and around the data science realm. It's not going to be. It really isn't. You are the front line. You're the folks that are going to be figuring out what are the problems, right? What are the variables that I want this data scientist to look at? Because maybe you don't understand necessarily what XGBoost does and how it works, but I can give you the tools to understand what's actually driving the problem, right? And then what you're going to be doing is becoming part of that collaboration. We call it vertical collaboration within Dataiku, where the person who builds out your data set, maybe in data engineering, that gets your extracts and make them ready for your Tableau. Well, what's going to happen next, right? You're going to be building those dashboards. You're trying to analyze what's happening. You're going to give that to the data scientist, because maybe the data scientist has no idea what your business is. You do. You spend all day, every day working in it. So you are part of that process of data engineering, data analysis, and then ultimately that data science. And what we're doing, we're trying to make that available to you. Just like what Interworks did when they built out their dashboard and they made it available to the Tableau community, that's going to continue and carry on over the next few years. Thank you so much. Thank you for spending time with me today. So take care and have a great rest of the conference.
Thank you.